Welcome to the final installment of the DRM-800A Denon. This one I'm going to do the testing on what was the subject of the last video of lapping the Ferrite erase head and coating it and trying to come up with a solution for the reported high frequency roll-off. And so I'll do those tests here. I'll start out with the Sony HF, which was reported to be the worst offender, and also was, in my own tests, was also the worst of all of them. And I'll be using the T100, the Nakamichi T100. I've got it set there at 15 kilohertz. I'll be using this to both generate the signal, and then because it's a nice visual, I'll be using it to measure the signal also. So what I'm doing here is making a tape 40 seconds long at 15 kilohertz. And then I'll have 10 playbacks, and I'll stop those playbacks at 30 seconds so that the last 10 seconds isn't touched. And then on the 10th and final playback, I will let it run through 30 to the 40 seconds. And then that will show an instant comparison between where the tape's been played 10 times and where it hasn't been played at all. And I think the proper way to conduct this test is to not use the monitored recording as, play 1 or play 0, even though it was really close on this particular deck at that frequency. It's not always the case, and I think just to do it the right way, we'll start off with the first playback being the first playback, not the monitored signal. And of course, I'll fast forward through all this. My first results using this tape were about 2 dB, minus 2 dB and minus 3 dB on the two channels following the first lapping I did in, I think, the first video, or maybe second. But this Sony tape was also kind of funky. It was newly open tape, but it wasn't, it had a lot of dropouts in it. Not only that, when I took it out, the pinch roller was absolutely littered with tape debris. So the first part of this tape wasn't very good, but I think it's okay at this point, or getting close to it. But I'll test more than just this one. Okay, so here we are on the 10th play. I'll slow it back down to regular speed. Okay, and you can see the monitored, or the playback signal there. Really difficult to see much in the way of attenuation. I know reading parallax on that T100, but it's either that or look at the back of my head. Okay, so at 30 seconds, I'll just let it continue and watch that meter, and there's 30, and there's the unplayed section of the tape. So did it jump a little bit? Yeah, maybe a couple of tenths. I'll play that back again because I know you'll rewind it and watch it, so I'll do it for you. And there it is. Did it move? I don't think much. On my previous tests, it did move. 2 dB and 3 dB. I should say we're looking at the middle scale on the T100 there. And I'm conducting this at minus 20 dB. Now this is the tape that the deck's biased for. I didn't rebias it for that Sony. This is the one that I care about mostly. So to show you here, I've kind of tried to reposition or add a little volume to this so that it looks more like it's on 0 to your view. It's about half a dB high from my view. Now this is the tape that Steve wanted it biased for, and so it's biased and optimized for this tape. I've done all the rest of the work on this. It's been fully recapped. I've done the I've also upgraded the signal path record and repro to the Nichicon Muse bipolars throughout. I've changed out the two 4066 noisemakers to the 4066 Max. I've also changed the first playback op amp over to a Burr Brown, and I did a lot of A/B testing with that. I didn't really hear much difference, but in the sonics, but it seemed quieter to me. So I'm leaving that one in there. I put it in a socket so it can be easily changed and tested. But I did like the sound of the quietude a little bit better. So I left that one in. Okay, so I'll be able to go back here and I'll switch just for visual between the tape and the source. Okay, here's playback number 1. You can see this tape is, the signal's much more stable than it was on that Sony Type 1 HF. We'll just let that play through to 40, and you can see I'm pretty well balanced here. We'll start to, I'll speed it up here, of course, go through these quickly. I'll just do the same thing at, on number 10, I'll slow it back down to normal speed and let it play through. Also had to put a new output pot on this. It needed a little bit of modification to make it work. It was the same Alps brand and the same model, but the shaft was a little shorter, had a little different mounting system. But the first cleaning on the trim pot lasted about a week, maybe 2 weeks, and then all of a sudden it started getting scratchy again. So I cleaned it a second time. It didn't behave itself. So I was lucky that I was able to find one that worked, but it wasn't a direct replacement. And the shaft is about an 1/8 inch shorter, and that's not a problem. I think I can make that work fine with the knob. Okay, not really seeing much attenuation there. Okay, we'll just let that play through all the way. The signal's steady. Again, this is at 15 kilohertz. I also did a few tests at 15 and 20 or 15.5 off the ST1500. I did 15 and 20, and the results were similar at both frequencies. Okay, here it is. Okay, did it move? Did it lose any volume? You can make your own determination. I'll just say now so that you can watch the meters. Okay, this is 30. So there you go. That's after the lapping that I showed in the last video, and I've also put 3 coats of the alpha graphene ceramic coating on it, and 24 hours between coats. So to my mind, I think I've got a viable solution. I don't know how long it will last, but you know, they're reporting 2 to 5 years of coating in a marine environment. That's pretty good. I think maybe once a year, and it takes no time at all. It takes 20 seconds, 30 seconds to put the coat on there, let it dry, and kind of just rub it off. So like I said, Steve, I'll find a little bottle to put some in and send it back with the deck. And, you know, 6 months, maybe a year, maybe you can report back to us and let us know what it does after a year before you recoat it. Okay, let's connect this up to the sound technology, and using the same tape that it's biased for, let's show the parameters and the final results of all the work. Get it over here so you can see it. Of course, I'm still not assembled. I've got frequency response here. I'll do a frequency sweep, and I'll just end it, this one at 400 hertz. What I want to see here is the high end, and it goes a little faster if I don't go all the way down to 20. I will go all the way down though and show that as well. Okay, this is the monitored recording. Pretty similar on this deck. There's not a lot of difference. That doesn't hold true of every deck. Okay, here's the played back signal. Now, Steve, this is set up to what sounds good to my ear. When I set it up to the factory specs, it's a little bit bright to me. And so I've got this sounding the way it, you know, A being it to a source signal to the point where it sounds the same to my ears. You can see I've got excellent frequency response, well within the envelope. I've got extension out to 25 kilohertz, and again, that's the played signal, not the recorded signal, not the monitored recorded signal. Sorry. But I'm also looking for uniformity, left to right channels. I do match capacitors in the signal path, and I think that helps to keep these 2 channels uniform. Okay, now here you can just barely see the bias knob there in the lower right corner. I've got it turned, I've got it under biased by about, you know, maybe at 10:30, 10 o'clock, 11 o'clock, in between those 2. Now this is the way the factory wants it set up. And you can see there's just a little bit more rise there in the high end. Either way, it's well within distortion figures, and it sounds good. It's just, I think it sounds better the way I have it set up. But that's why that knob's there. So you can, and I'm sure you may have to tune it to your exact tape that you have there. But it's pretty close. Okay, let's do the full frequency sweep now, all the way down to 20. This is pretty impressive. This is a great sounding deck also, by the way. I wouldn't mind having one of these myself. It's not the easiest to work on, transport-wise. I do like the circuit boards. Everything is pretty modular with connectors, and so that makes it nice. Mostly. There are some of those wound wires that I don't like, but not bad. Okay, so this is down at 24 hertz. This is the lowest that it gets down, and then it comes back up a little bit as you get down to 20. So this is well within the 3 dB envelope, and it lacks absolutely nothing on the low end. It reproduces that beautifully. As you can see my datum here. Okay, let's do this now with adding a distortion tone at the end of a short sweep. Okay, let's increase that just a little bit, get it up to 0 or closer to 0 dB. Okay, so 1.4 on the left channel. I always expect the left channel to be a little bit higher. Nothing wrong with that. We'll do a full distortion sweep on it also. Let's look at the what the noise floor looks like. And again, I'm not just looking exactly for a number, but I'm looking for uniformity between channels. And I think I could probably call this just over half a dB, certainly under 1 dB, or thereabouts. So I don't have a problem with that. Let's check the Dolby. That was no Dolby. Let's check the Dolby C on this. So around minus 71 dB, and that's with no top on it. A lot of the shielding is still not in place. I've still have certain grounds hooked up with alligator leads, and the faceplate isn't on. And the faceplate is also a aluminum shield. So I'll take that number. I think 76 is the factory spec on it. Let's throw the old tried and true and very, very tired RCA wound flutter tape in there. I'm trying to get the last the last little bit I can out of this one. It's probably actually the best one I have, even though it's worn and it's got dropouts. It's probably the lowest. When I do find a good spot in it, it's probably the lowest of any tape I have. Okay, so around point, anything in the 4s I'll take. 4 to 5, 0.04 something to 0.05 something I'm very happy with, keeping in mind that these are factory belts are not available for this, nor are the exact correct sizes. So anything in the range of 0.05 I'm happy with. Let's check our speed again, and wow, why is this so high? Did I forget to set this? I can't remember. I find these that have the speeded pot in the back of the motor behind a rubber grommet very difficult to set, because when you go to retract the screwdriver, it always changes it, and it's just a very touchy thing. Maybe right about in through here somewhere should be good. Right about there. Let's see if it holds. Okay. I'll check this one more time before I button it up. I still don't have the anti-resonance cassette accessory in here, so it might change things just a little bit. But speaking of that, I also need to test or reset my azimuth, or at least check it after putting that in. Okay, so following adjusting the speed, I'm still in pretty good shape here. This is one of those decks that the capstan only spins when the play is pushed. And so I'm not a big fan of that because it takes time for it to stabilize. And, it's just not, I mean, yes, it wears things out less than the other types do, but honestly, the decks that the capstan rotates when the cassette's inserted, I find to be the most reliable. And, I've been in a lot of them, and I've never seen any sort of outrageous wear. And a lot of the ones I work on came out of studios and radio stations. And so I'm still a fan of that. Okay, this is just the last homemade wound flutter tape I made. And just a curiosity thing, just to see how close this one is on this deck to the other. And this was made on a single capstan machine. So, if I was expecting to see variation, I would expect to see it here. And it's a little bit higher, maybe 15% higher, maybe 20. That was just for my own curiosity. Okay, I'd like to run a distortion sweep on this now using the tape that it's biased for, and actually put numbers to what I think I heard doing recording. You can see this is maxing out the meters. And I'll speed through this also. This takes quite a bit of time. Okay, let's have a look here. So they're basically looking for 3% distortion, and I don't think they gave an amplitude on that. I'll have to check that. In fact, hold on. Well, I just had a quick look at the manual, and I don't see any numbers listed for distortion. I even did a search function on the PDF, and I didn't see the word distortion in there. So anyway, it might be there, but I didn't see it here just stopping and looking. So basically what I saw was confirmed, or what I thought I heard was confirmed with the results here. It's between 4 and 5 dB, between plus 4 and 5 dB. It's going from 1.9 or 1.8 and then at 5 it's at over 3%. And so what I thought I heard was backed up by the numbers here. So you can hit it to about 4 dB, plus 4 dB, Steve. Unless you like distortion. Now, I don't have the exact correct ABEX tape they're asking for on this, and my camera died there. So, okay, we'll put back this dampener and then check the azimuth on this. Is that it? Feels okay. Azimuth tape. Nope, I don't think I got the top snapped in. Nope, I didn't. Okay, there it is. Grab my socket here in case I need to make an adjustment. Probably will. Okay, just a little tiny bit off. Between 40 and 60 degrees. Okay, just very gently remove that. Yeah, let's do it one more time. This is just again, these are just about the smallest movements a guy can possibly make. Okay, I like that. There it is. Get it out of there. Okay, I'm happy with that. Okay, so it was probably fluctuating between plus and minus 8 degrees. Perfectly acceptable. Okay, we'll lock these things down now. Now, my own personal method for doing this is to use the standard 3-bond. I think it's 1401. And then I like to follow that up with some brightly colored torque seal. I'll just put a little drop on there. I'll do the other 2 screws as well. One of the problems for me anyway with the colored torque seal is that I really can't tell if it's without a magnifying glass, if it's moved at all or cracked. And so what I do is I follow it up with this a torque seal, which is almost like a fluorescent color. And when the nut or the screw or whatever moves, it's really easily apparent. It looks like a giant crack in there when it moves, and that's the purpose of this. And so it's very easy every time you open the well just to see if there's a crack in there. And I can't do that with the torque seal. I'm sorry, with the screw seal. I still do archiving occasionally for people, and it makes me comfortable when I can look in there between tapes and see that nothing's moved. So that's what it looks like. Even the picture here doesn't really show how kind of fluorescent or bright this material is. So there it is. This was an interesting learning experience on these ferrite heads, erase heads, learning how to deal with that and lap it and get the results that I'm looking for on these. So Steve, I ended up shielding that display cable with Faraday cloth and copper tape, and I'll be getting a few more hours of runtime on this, and then back to you it comes. So I hope you all enjoyed this series. Check out the other videos in the playlist, and as always, thank you for watching.